Welcome, future AI whisperers, to the magical realm of NumPy. Now, this is video 9 out of 20 in a beginner series and introduction to AI. Now, all those neural network concepts store weights, biases, and even information within their architecture as numbers. So, you might be wondering, what is NumPy anyway? Well, NumPy is short for Numerical Python, and it is a library that gives Python the power to work with large arrays and matrices of different types of numerical data. And this is essential for computer vision tasks. Likewise, in the realm of language processing, NumPy arrays hold the power to represent words and sentences as numerical vectors, making it indispensable for natural language processing and generative AI. Whether you're conjuring word embeddings or crafting generative spells, NumPy is the underlying sorcery that makes it all possible. So let's jump to the code. First, I'm going to create this import script. This essentially, as we've done in previous exercises, allows you to unleash the first step to wielding the magic behind NumPy. Now, you might be wondering why we care about NumPy for machine learning. And the answer is that in the world of computer vision, we are able to actually use these to represent data as arrays. So let's jump into the concept of arrays. The array is a data structure that is at the heart of NumPy. Simply put, an array is a grid value, all of the same type. Let's make one right now together. And then let me print its dimensionality. Here, you're seeing it as open bracket 0, 2, 4, 6. And from here, you have a 1D array, which is like a row. But why don't we add another row and make it a two-dimensional algorithm? This will look like this. Notice that there's actually two brackets, where each of these is basically a smaller row that then stacks on top of each other. So let's print this, and you'll see that now we have two-dimensional arrays. And there you have it. Suddenly, we can now enjoy our 2D matrix. Also notice that unlike our first example, I actually have the two brackets here. And this is the concept of nesting. But essentially, you're not only defining the matrix, you're also illustrating how your matrix nests within itself. So there are two brackets in the 2D array, and there was only one initial bracket in the 1D array. This will become key in more advanced classes, but for now, let's turn to the 5 main functions and operations that you'll definitely want to know how to do work with in NumPy. First, we'll quickly teach you the magical spell to quickly discover your array's current shape, and then the method to reshape it to your liking. The general rule is that we use rows, then columns as our rulebook. Therefore, if you print out the following shape, it will say 3, 2. Which tells us that we have 3 rows and 2 columns in our data. So now, we'll simply reshape our matrix, and maybe you can even take a look at it this time to instead have 2 rows and 3 columns. So here I'm reshaping it, and you'll notice actually that there was weird syntax, so this is good. Let me just use a different name. We'll call it 2dim reshape. And then let me also change the name of this object to print out that two-dimensional reshape. And you'll now see that in this action, you transformed your array's shape like magic. Now, the second most common task that often gets forgotten or ignored is the need to conjure arrays filled with zeros and ones. So here's how we do it. I'll call this the zero matrix. You call the NumPy library and you just call it zeros. And then you can actually define it to have 2's inside of it. So there we go. And then I'll print zeros. Sorry, zero matrix. And you'll see that we created this. Similarly, we can also create a 1 matrix, which is literally the same thing, except you do NP 1s. And we can also populate it just like this. And if you want to print it again and just check it out, this is what it looks like. Now, it might not be apparent just yet, but this is perfect for initializing those vector or image masks and filters that you'll be using later in your journey. Now, the third operation that NumPy commonly relies on is performing arithmetic operations, but without those super annoying loops. Now, of course, there are some rules that you've got to know from linear algebra, but they're pretty common sense. Like, the matrices just have to be compatible. So, let's take a quick look and make some matrices. let's bind to our A variable an array that is a simple row of 2, 2, and 2. And then let's also create and bind an array to variable B, and let's call it 8, 8, 8. Pretty much, I can just add these two because they have the same dimensionality, and voila, 2 plus 8 is 10, and we have 3 10s. Notice how you didn't have to actually make a for loop to iterate through each element or row. It's awesome. It's sort of like having little math elves in the machine doing the math for you. Okay, so now the fourth operation that you'll learn is something known as the dot product, a go-to spell for common matrix magic. So let's hop in, and this time, let me show you what happens if you click on output dot AB. I simply take the output of those variables above. You then actually multiply all of them together to get 48. Now, I can't stress this enough, and it might seem basic now, but this operation is pretty critical for any type of neural network computation. And now we're at the final step, and this is about how we can actually slice through those matrices to allow peering into underlying sections of your array with a method known as slicing. So I'm going to create a new matrix. We'll call him matrix, very creative. And then I'll define a new array. We'll make him 2 dimensions, and we'll make it pretty standard. We'll just count up to 6. Great. 7, 8, 9. Nice. And now if I print out on this matrix, let's say that I want to just slice out the first 2 values, and then from 1 to 3. Let's check out what that looks like. And here, you've successfully extracted a subsection of your common matrix, getting a 3 by 3 counting matrix. Because now we simply returned 2 to 3 and then 5 to 6 of that broader matrix. All right, this is video 9 out of 20 in our beginner series and introduction to AI. By the end of the series, you'll be ready to learn more advanced concepts of AI and machine learning, which will allow you to elevate your career in tech and remain in demand on the job market. And there you have it, AI Whisperers. With the power of NumPy, you have now become appropriately equipped to conjure the initial steps for computer vision and natural language processing. Dive into the world of vectorized images, sentences, matrices, and algorithms, and let your AI engineering journey begin.